Integration represents integration is an elongation of S which represents the sum, that is the sum of the series that we have, as we have proved above. Third, this type of integration was found by Archimedes far before differentiation was known. That is why it is often regarded as the fundamental theorem of calculus and is called Archimedes' method. Fourth, since h is equal to b minus a upon n, as n tends to infinity, h tends to 0. We take an example. Evaluate a to b x square dx as the limit of sum. Fx is equal to x square. A to b fx dx, as we have established, is the sum, the limit of the sum, limit h tends to 0, h summation of r going from 1 to n f of a plus rh, which is limit h tends to 0, h times r going from 1 to n, f of a plus rh becomes a plus rh whole square, which is equal to limit h tends to 0, h summation r going from 1 to n, we expand a plus rh whole square becomes a square plus 2rh plus r square h square, which is equal to limit h tends to 0, h times a square n, because a square will be repeated in every term, which is n times, plus 2h times summation r going from 1 to n, plus h square times summation r square, r going from 1 to n. We know sigma r becomes the sum 1 plus 2 plus 3 plus so on up to n becomes n into n plus 1 by 2. And summation r square becomes n into n plus 1 into 2n plus 1 divided by 6. Applying these values, we get limit h tends to 0, a square nh plus 2h times n into n plus 1 by 2, that is the value of sigma r, plus h square times sigma r square becomes n into n plus 1 into 2n plus 1 by 6. Finding the limit of this as h tends to 0 or n tends to infinity, as we have established above, but nh goes to b minus a. As n tends to infinity, as I told you, h tends to 0 and h is equal to b minus a, we get limit h tends to 0, a square times nh plus a times nh into nh plus h plus nh times nh plus h into 2nh plus h upon 6. We have distributed h into the inside. Now putting nh equal to b minus a and h goes to 0 wherever it is separate, we get a square times b minus a plus a times b minus a into b minus a plus b minus a into b minus a into 2 times b minus a upon 6. We can pull out b minus a upon 3 common. We get b minus a upon 3 times 3a square plus 3ab minus 3a square plus a square plus b square minus 2ab, which comes out to be 1 by 3 times b cube minus a cube. We take another example of evaluation of a to b c raised to power x dx, where c is not 1 but c is greater than 0 as the limit of sum. Here fx is equal to c raised to power x. Therefore, by definition of the limit of sum, a to b, integral a to b c raised to power x dx is equal to limit h tends to 0, h times summation r going from 1 to n f of a plus rh. That's equal to limit h tends to 0, h times summation r going from 1 to n c raised to power a plus rh. If we expand it, we get limit h tends to 0, h times c raised to power a into c raised to power h plus c raised to the power 2h plus c raised to the power 3h plus so on c raised to the power nh. Clearly, it's a geometric progression which first term c raised to the power h and common ratio also as c raised to the power h.